to apply rational functions by solving pretty simple word problems. Okay, we call these work problems because they involve putting together different people's work rates to see what their combined work rate would be. And actually, this is something I used all the time when I worked I was a manager of a financial marketing group, and we had to come up with a rate to charge different contracts. Like, for instance, when we redid all the air traffic control towers for the FAA. Yeah.
Salary higher than being a teacher?
Oh, way ahead.
Oh my gosh.
Yeah, more than half higher.
What are you telling me?
And so, when I was bidding the contract, like, I couldn't say Bailey was always going to work on that one contract or Derek was always going to work on that contract. So I wanted to put together a rate so that it was like an average rate, so that whoever worked on it, I would get a certain amount of money for that, for somebody working. Okay, but I couldn't say specifically who was working on it. It was just sort of an aggregate of lots of people's rates. Okay, and so I actually use this sort of setup to do that. All right, so the first thing you need to do is figure out what every person that's involved's rate is per job. All right, so the way you do that is you think, how much can be accomplished in 1 hour? So if Nick can paint a room in 5 hours, how much of the room can he paint in 1 hour? 1/5, exactly. So his rate is 1/5. Okay? Allie can paint a room in 3.5 hours. So in 1 hour, how much of the room could she paint? 1 over 3.5, right? Okay? And together they can paint a room in T hours, so their rate would be 1 over T. Okay? And it's going to be more or less than 5 and 3.5? Less, because they're working together, so hopefully they do it faster, right? Yeah. So hopefully they'll get it done overall faster. All right? Now, one thing you got to remember in these types of problems, these one-job problems, you're going to have like measurements, feet, and you're going to have number of pages typed, and lots of different things. But you're only concerned with what job are they accomplishing? Okay? Like, for instance, this one. Working alone, Ryan can dig a 10-foot by 10-foot hole in 5 hours. What's the job?
Digging a hole.
Digging the hole. No matter what size it is, 10 by 10, 20 by 20, whatever it is, that's the job. Okay? So if he can accomplish it in 5 hours, how much of it can he accomplish in 1 hour? 1/5, right? Castell can dig the same hole in 6 hours. So what's his rate? 1/6. So don't get, the one thing that trips people up a lot is they try to put these numbers into the problem somehow. But that's just describing the job. It really doesn't have anything to do with the problem. Okay? Well, if the job changes, we have to redo the calculations entirely anyway. Because I'm sure his rate, if it's a 20 by 20 hole, I'm sure you can't do it in 5 hours anymore. I'm sure that will change. All right, so I put Ryan's rate, which is what you told me 1/5, plus Castell's rate, which you told me was 1/6. And if they work together, their rate is 1 over T. Okay, now let's use what we know. I got to get common denominators. What's the common denominator going to be for all these? 30T, right? So for this one, I'll write the common denominator, but hopefully after that we won't have to. So I got 3 30Ts. Okay, what's the top of this fraction going to be to get to 30T? What do I have to multiply 5 by? 6T. So the top of that fraction would be 6T. What would the top of this one be?
5T.
5T. And the top of that one? Just 30, right? Because we already have the t there. Okay? Because I'm adding and it's an equation, I can cancel out the denominators. And that gives me 11t equals 30. How do I solve for t? Divide by 11. No, it's like 2.82 and 8, 11. So I'm going to be like 2.7 something.
One can dig it in 5 hours, one can dig it in 6 hours. Average it out. It's only 2 people, so.
Right, but they're not, it's not one person digging for that 5.5 hours. It's them digging together. So it's going to be way less. Okay, so what would that be? That's a good point. Does everybody understand that? We're talking about them both digging the same hole together. So it's 2 point, Zach, did you do it? 2.7 something? 2.72. Is that rounded right?
Oh, wait, no.
2.73. So so they could do it together in about 2 3/4 hours. Okay? And that if you were trying to look for a way to make sense of that number, like if they both dug the hole, if it took them both 5 hours, how long would it take them together? 2.5, right? So we're expecting, because they're both can work, right? So we're expecting this to be, since this was 6 hours, we're expecting this to be a little more than 2.5. So that's if you're looking for a way to just make sure that it makes sense. All right, take a minute and do the Shauna problem, the concrete driveway. And if you get done, raise your hand, let me check it, and then go ahead and do number 3, but don't do number 4 because I'm going to add a different kind of problem. One job, okay, to complete one job, one lawn, one ditch, one roof, one whatever, okay, one driveway. If you're going to do more than one job, like Rachel can mow 4 lawns in 7 hours, Deshaun can mow 6 lawns in 5 hours, okay, how long would it take them to mow 8 lawns together? So there's more than one job there, right? We can tell because she mows a different number of lawns than he does. Okay? So the way we set up these problems is we take a piece of the total rate. So if you make X be the rate they work together, her rate is 4 to 7 times, all right, 4 lawns in 7 hours times the rate. Okay, we can make that big if you want. Plus his rate, which is 6 lawns in 5 hours times their rate together. And when you use both rates, you're going to get 8 lawns done. Okay, so that's her part of doing 8 lawns together, his part of doing 8 lawns together, and you'll get 8 lawns done. Okay, so picture this more like this. What's the common denominator? 35. It's easy, right? We don't even have a variable in there. So I'm going to multiply both sides, all 3 of these by 35. This one's going to be 20x over 35. This one's going to be 42x over 25, or over 35, sorry. This is going to be 8 times 35, which is 280 over 35. Okay, cross out the 35s. And I get 62x equals 280. Divide by 62, and I get what? How long is it going to take them to do 8 lawns? I'm sorry? Right, 4.52, about 4.5 hours. Okay? Try the last one there.
The warehouse one?
Oh, sorry. Never mind, I didn't have an extra one of those. So everybody understand that, though? That's for more than one job. All right, then there's the final type. Okay, and that is if they told you what it took them to do the job together, and you're trying to figure out what it would take one of them to do the job alone. Okay, so we're going to use the same setup as we did for the one job problems. It says working together, Paul and Daniel can pick 40 bushels of apples in 4.95 hours. So their together rate is 1 over 4.95. That's how much they could do in an hour. Okay, but their individual rates, Daniel can do 1/9 of his work in an hour. Paul, we're still looking. So that's whatever his rate is, 1 over P. What's my common denominator going to be there?
9.
How would I figure it out?
Take
9P and 4.95 and multiply them all together. So 9 times 4.95 is 44 point something. 44.55. All right, so if I multiply this one by 44.95p, I get 4.95p. If I multiply this one by 44.55p, I get 44.55. And if I multiply this one by 44.55p, I get 9p. Okay? Then I subtract 4.95p from both sides. That gives me 44.55 equals 4.05p. Divide by 4.05. And I think I get 11, right? Okay, 11.09. Okay? So these kind of work the same way, just you've got a different variable, a different place for the variable. Instead of at the end, it's in the middle. All right, try the last one, and I'll let you get started.